Topic 8, Probability. Subtopic 8.1, Events and Probability. Learning outcomes. At the end of this lesson, students should be able to find the probabilities of the intersections and union of two events. So first, we're going to have a look at the complement of event A. So this can be illustrated by using Venn diagram. So in this Venn diagram, we can see that there is event A in the circle, and outside the circle we have event A prime. What is event A prime? Event A prime is not A, okay, but it is still within the sample space region. So what is the probability of A prime? So A prime meaning the complement of event A, not an A. Alright, it consists of all elements in the S that do not belong to A. The possibility that A will not occur. Next, we're going to have a look at unions and intersection of event. So additional probability rules, probability A union B equals to probability of A plus probability of B minus with the probability of intersection between A and B. So probability A union B is the union of A and B, which is the set of all elements that belongs to A or B or both. So please take note that probability A union B equals to the probability of B union A. So if we illustrate using Venn diagram, we can see the shaded region is what we mean by probability A union B. Next, we're going to have a look at PA intersect B. So what is it? It is the intersection of A and B, where it is the elements in common with the A and B. So please take note that PA intersect B is also equal to probability of B intersect with A. So as we can see in the Venn diagram, so A intersect B is just this region. What if we have three events, A, B, and C? If we find the union between all these three events, PA union B union C equals to probability of A plus probability of B plus probability of C minus with the intersection between A and B minus intersection between B and C minus intersection between A and C and plus intersection between A, B, and C. Okay, so if we follow the formula, we can get the probability of this shaded region. Okay, what does it mean by A intersect B equals to empty sets? It means there is no intersection between A and B. A is a subset of B. It also means A intersect B equals to A, meaning the whole A is within event B. Next, we're going to have a look at the De Morgan rule. So what is De Morgan rule? Probability of A prime union B prime equal to probability of A intersect B prime. Okay, and probability of A prime intersect B prime is also equal to probability of A union B prime. So De Morgan rule can be seen from the Venn diagram. So right now we're talking about A prime union B prime, not an A. So if you can't remember the De Morgan rule, we can also find the meaning of probability A prime union B prime by using Venn diagram. So first, A prime, what does it mean by A prime? Not an A. So we try to shade the region which is not an A. Okay, next, the events involved is B prime. So next we try to shade not B. So everything is not B, everything outside B. Alright, so we know that when we talk about union, it means set of all elements that belongs to A or B or both. So in this case, it is set of all elements that belong to A prime and B prime or both. So as we can see here, it means everything in this region that is shaded. So everything in the sample space except for the intersection between A and B. So that's why PA prime union B prime equals to probability of A intersect B prime. Everything that is not A intersect B. So we try to do the same for PA prime intersect B prime. So we shade the events involved, which is A prime and B prime. So event A prime is not an A. Okay, I shade it using the blue pen. And event B prime is not event B. Everything is not B. So I shade it using red pen. So when we talk about intersection is the set of elements in common with A and B. So here, the set of elements which is in common with A prime and B prime. So the area which has common elements is the one outside, where we can see there's overlap between the red and the blue pen. So as we can see here, the shaded region is everything except for A union B. So that's why we get PA union B prime. Okay, next we have contingency table. So for contingency table, the first row, we're going to put A and A prime in the first row, and we're going to put B and B prime in the first column. So the entries are as follows. Okay, so the first row, first column is probability of A intersect B. First row, second column is probability of A prime intersect B. Second row, first column is probability A intersect B prime. Second row, second column is probability A prime intersect B prime. Total probability for the first row is probability of B. Total probability for the second row is probability of B prime. Total probability for the first column is probability of A. Total probability for the second column is probability of A prime. So if we sum probability of A and probability of A prime, we should get a total 1. Next, exhaustive events. So the two events A and B are said to be exhaustive events if number of A union B equals to number of sample space. For example, we have A1, A2, A3 up to A7. So the number of A1 union A2 union A3 up to A7 equals to the number of sample space. Example 7. A statistical experiment has 8 equally likely outcomes that are denoted by 1, 2, 3, 4, 5, 6, 7, and 8, where A is 5, 7, where B consists of 1, 2, and 5, C consists of 1, 4, 6, and 8. So we're going to use one of these three methods to illustrate our event. So we cannot use table since we have 3 events. Table is restricted if we have 2 events or 2 actions at the same time. We can use Venn diagram to illustrate these 3 experiments. These 3 events, A, B, and C. Okay, so we're going to have 3 circles. So circle A, circle B, and circle C. So why do I make them overlap? Because as you can see, in these 3 events, we have overlapping numbers. So this is event B, this is event A. So event A, there's number 7, but we're going to put number 5 in the intersection between A and B, because in B we also have number 5. So for B we have number 1. We're going to put 1 inside the intersection between B and C, since C also have number 1. Next we're going to put number 2. So in C we're going to put number 4, 6 and 8. So there's still remaining number, which is number 3. So number 3 is put outside the circles, but still within the sample space. So we're going to put a box to represent the sample space. Okay, so are the events A, B, and C exhaustive? So what is exhaustive events? If we look at the previous note, the 2 events are said to be exhaustive events if the number of all the events is equal to the number in the sample space. So since the number of event A union event B union event C is not equal to the number of sample space, therefore event A, B, and C are not exhaustive. Next, we have to find the probability of A union C. When we have P A union C equals to, according to the formula, equal to PA plus probability of C minus probability of A intersect C. So altogether in the sample space we have 8 numbers. So probability of A, in event A we have 2 numbers, so 2 out of 8 plus probability of C. So in event C we have 4 numbers, so 4 over 8 minus the probability of A intersect C. So as you can see here, A does not intersect with C, so there is no intersection between A and C, so minus 0. So 2 over 8 plus 4 over 8, we're going to get 6 over 8, which can be simplified as 6 over 8. Example 8, given A and B are 2 events where probability of A equals to 1 over 3, probability of B equals to 5 over 9, and probability of A intersect B equals to 1 over 6. So we have to find probability of A union B. So if we have probability of A union B, we can use the formula probability of A plus probability of B minus probability of A intersect B. So which equal to 1 over 3 plus 5 over 9 minus 1 over 6. So if you calculate using calculator, you should get your answer as 13 over 18. So next, we have to find the probability of A intersect B prime. So what is probability of A intersect B prime? So it's either you use the Venn diagram to find probability of A intersect B prime, or you can just refer to the contingency table. So according to the contingency table, okay, probability of A intersect B prime is here. So we can find probability of A intersect B prime if we subtract PA intersect B from PA. So PA intersect B prime equal to PA minus PA intersect P. So PA equal to 1 over 3 minus A intersect B, so which is 1 over 6. So we're going to get 1 over 6 as the answer. So next, C, probability of A prime union B prime. So according to the De Morgan's rule, so this equal to probability of A intersect B prime. So what is probability of A intersect B prime? So it is not probability of A intersect B. So 1 minus probability of A intersect B, which equals to 1 minus 1 over 6, which equal to 5 over 6. And what is probability of A prime intersect B prime? According to De Morgan's rule, it means probability of A union B prime. So what is probability of A union B prime? Meaning probability of not A union B, or 1 minus probability of A union B, which equals to 1 minus 13 over 18, which equals to 5 over 18.
Finding probability involving combination and permutation. Example 9, 4 letters are chosen randomly from the word computer. Okey, so kalau ikutkan dalam perkataan komputer, kita ada 8 huruf. Okey, cara untuk kita pilih 4 letters daripada 8 huruf ni adalah A choose 4. Kalau kita tekan calculator, kita dapat 70. Jadi bermaksud there are 70 ways to choose 4 letters from the word computer. For part A, we have to find the probability that all the 4 letters chosen are consonant. So, kalau kita tengok huruf ni, perkataan komputer, huruf konsonan adalah C, M, P, T dengan R. So, cara untuk kita pilih, dia ada 5 konsonan altogether. Jadi, cara untuk kita pilih daripada 5 konsonan ni, 4 letters adalah 5, choose 4. Okay, bila kita tekan calculator, jawapan yang dia bagi adalah 5. So, probability of getting all 4 letters are consonant adalah 5 over the all possible outcomes, 70. So, 5 over 70 can still be simplified. Dia akan jadi 1 over 14. Okay, next. For part B, the letter C must be chosen. So, cara untuk kita kira apa-apa pun letter C must be chosen. So, ada satu sahaja C. Jadi, daripada satu C ni, kita memang nak pilih C. Kemudian, kita ada lagi remaining 3 letters yang kita kena choose. So, daripada perkataan komputer ni, dah pilih satu huruf, which is C, tolak C. Jadi, baki yang tinggal adalah 7 huruf lagi. Dan daripada 7 huruf ni, kita nak pilih lagi 3 sebab kita nak choose 4. So, number of event kita kalau ikutkan dalam kes ni, 1C1 times 7C3. So, bila kita tekan calculator, kita akan dapat jawapan 35. So, the probability of the letter C must be chosen is 35 divided by the all possible outcomes, which is 70. So, 35 divided by 70 can be simplified as 1 over 2. So, that is the answer for B. And last part for C, the letters M and P must be chosen simultaneously. Okay, dia kena choose serentak. Okay, so untuk event C, nak pilih huruf M dengan P serentak. So, M ada satu huruf, P ada satu huruf. So, daripada dua huruf ni, M dengan P, kita memang nak choose dua-dua ni serentak. Okay, so darab dengan baki huruf yang masih belum dipilih, 8 tolak 2, jadi baki tinggal 6. Dan daripada 6 huruf ni, kita perlu pilih lagi 2 huruf untuk cukupkan 4 letters. Okay, so bila kita tekan calculator 2C2 times 6C2, we get 15. So, the probability of the letters M and P to be chosen simultaneously is 15 divided by all possible outcomes, which is 70. So, 15 divided by 70 can still be simplified. The answer that we get is 3 over 14.
Example 10. 3 identical red marbles, 4 identical yellow marbles, and 2 identical green marbles are arranged in one row on a table. So, the number of red marbles is 3, the number of yellow marbles is 4, and the number of green marbles is 2. So we have to find the probability that all the yellow marbles must be next to each other. Alright, so altogether, we have 3 plus 4, 7 plus 2, we have 9 marbles altogether. So we have to arrange it in one row. So the number of sample space here is when we arrange the marbles with no restriction. So 9 prime divide by, since we have 3 same red marbles, so divide by 3 factorial. So divide by 4 factorial, since we have 4 identical yellow marbles. Divide by 2 factorial, since we have 2 identical green marbles. So the answer is 1260. So we have to find the ways to arrange all the 4 yellow marbles next to each other. So macam mana kita nak susun? Kita akan ikat dulu all the yellow marbles. 1, 2, 3, 4 yellow marbles. So we count it as one unit. So the rest yang tinggal adalah 3 red marbles and 2 green marbles. So we need to arrange all these marbles. So we count it as one unit. 2, 3, 4, 5 and 6. So there are 6 marbles altogether. So kita akan kira dia sebagai 6 prime. Divide by, sebab kita ada 3 identical red marbles, so divide by 3 factorial. Divide by also 2 factorial since we have 2 identical green marbles. Okay, kemudian kita boleh nak darab dengan yellow marbles. So arrangement of yellow marbles dalam group yellow marbles. So since there are 4 yellow marbles, we divide by 4 factorial. Sebab we have to arrange 4 yellow marbles, then we have 4 identical yellow marbles. So bila kita kira, kita akan dapat jawapan sebagai 60. So the probability of getting A, where A is the event such that all the yellow marbles must be next to each other, is 60 over 1260. So this can be simplified as 1 over 21. So next, we have to arrange the marbles such that the green marbles must be in the first and the last position of the row. So there is a specific condition or specific location for the green marbles, the first position and the last position. So there is no green marbles left to arrange in between the first and the last position. So what's left is just 3 red marbles and 4 yellow marbles within the green marble. So untuk green marbles, kita ada satu je pilihan untuk kita letak dekat first position, satu je pilihan untuk kita letak dekat last position. In between the green marbles, kita ada 7 marbles altogether, so 7 factorial. Divide by 3 factorial since we have 3 identical red marbles, and divide by 4 factorials since we have 4 identical yellow marbles. So bila kita kira, kita akan dapat 35. So probability of green marbles in the first and last position of the row equals to 35 divided by the number of sample space, which is 1260. This can be simplified as 1 over 36.
Chapter 8, page 11. Example 11. A 5-digit number is to be formed from digits 2, 3, 5, 7, 8 and repetitions are not allowed. Event A, number is even. Event B, number is odd. Event C, number is greater than 60,000. So find PA. First of all, we need to find the number of outcome in the sample space. Let's write that as NS. Okay. So you have 5 digits to choose from. The first number, you have 5 options, and then you'll be left with 4 digits, and then 3, 2, 1. So NS is equal to 5 times 4 times 3 times 2 times 1. That is equal to 120. And then NA. So if the number is even, okay, you have 2 options for this one here, either 2 or 8. So the last number will be either 2 or 8. So you have 2 options. Once you have picked the last number, you have 4 more options, and then 3, 2, 1. So NA will be equal to 4 times 3 times 2 times 1 times 2. That gives you 48. So the probability of even A is 48 over 120, or 2 over 5. Okay, for PB, odd number, you have 3 options, either 3, 5 or 7. So for the last digit, you have 3 options. Then once you have picked the last number, you are left with 4 other digits to choose from, and then 3, 2, 1. So NB will be equal to 4 times 3 times 2 times 1 times 3. And that gives you 72. So PB is equal to 72 over 120, or 3 over 5. Okay. As you can see, the number is going to be either odd or even. So you can see that PA and PB add up to 1. 2 over 5 plus 3 over 5 is equal to 1. Right, for PC, if you want to make sure the number is greater than 60,000, you have 2 options for the first digit, either 7 or 8. So you have 2 options to choose from. And then the next digit, you have 4 options, and 3, 2, 1. So NC will be equal to 2 times 4 times 3 times 2 times 1. That gives you 48. Then PC is equal to 48 over 120, or 2 over 5. Question D. Probability A intercepts C. You have 2 cases. Case 1, the first digit is 7. Case 2, the first digit is 8. Okay, because you want it to be more than 60,000. So the first digit must be greater than 6. Now let's take a look at the last digit for case 1. So if you have chosen 7 for the first digit, you'll have 2 or 8 for the last digit because you want it to be even. So that's two options. This is one. And then you'll be left with three other digits. So three options here, two options, and then one option. For case 2, if you have chosen 8 for the first digit, you will have no other choice than to pick number 2 here. So you have one option here and one option here. Then you'll be left with 3 digits and then 2 and 1. So the number of A intercept C will be 1 times 3 times 2 times 1 times 2, or, which is plus 1 times 3 times 2 times 1 times 1. Okay, so you can see that. Okay, this gives you 18, and then P A intercept C will be 18 over 120, or 3 over 20. Next question. P union C. Sorry, P A union C. Okay, you can just use the formula. So PA plus PC minus PA intercept C. PA is 2 over 5 plus PC 2 over 5 minus PA intercept C 3 over 20. That gives you 13 over 20. Right, so for PA intercept B, this will be equal to 0. Okay, because it is impossible for a number to be odd and even at the same time. Page 12, some notes on mutual exclusivity. Two events A and B are called mutually exclusive if both the events A and B cannot happen together, or they have no elements in common. That means A intercept B is equal to empty set. If event A happens, then event B cannot happen, or you can say that only one of the events can occur at one time. The probability of both events occurring is 0. Example, the event obtaining an even number and the event obtaining an odd number are mutually exclusive. Let's take a look at the Venn diagram, A and B. It is obvious that there is no intersection between A and B, and we can say that A intercept B is equal to empty set. Since additional rule, since the probability of A intercept B is 0, then the probability of A union B is equal to the probability of A plus probability of B. If n events x1, x2, x3, up until xn are mutually exclusive, then the probability of x1, x2, x3 up until xn is equal to the probability of x1 plus the probability of x2 plus the probability of x3 plus up until the probability of xn. Example 12. A box contains 3 glazed donuts, 4 jelly donuts, and 5 chocolate donuts. If a person selects one donut at random, find the probability that it is either a glazed donut or a chocolate donut. So let's find the number of outcomes in the sample space first. And S equals 3 plus 4 plus 5 gives you 12. And let's label the event of selecting a glazed donut as G, and then J for jelly and C for chocolate. The question is asking for the probability of G or C. From the question, we can understand that a donut can't be a glazed donut and a chocolate donut at the same time. So that means G and C are mutually exclusive events. Then we can just use the formula given in the notes. This is equal to PG plus BC equals 3 over 12 plus 5 over 12. Simplify and you'll get 2 over 3. Example 13. A day of the week is selected at random. Find the probability that it is a weekend day. There are 7 days in a week, and the probability of selecting a specific day of the week is 1 over 7. The question is asking for the probability of weekend, which is either Saturday or Sunday. We know that Sunday and Saturday are two mutually exclusive events. So P Saturday plus P Sunday. One over 7 plus 1 over 7. That gives you 2 over 7. Example 14. A bag contains 4 red marbles, 2 white marbles, and 8 black marbles. What is the probability that a marble picked from the bag at random is either red or white? So again, the sample space, 4 plus 2 plus 8 equals 14. The probability of picking a red or white, since they are mutually exclusive events, you can say that this is equal to PR plus PW equals 4 over 14 plus 2 over 14. That gives you 3 over 7. Example 15. The events A, B, C, and D are mutually exclusive with PA equals PB equals 0.3 and PC equals PD equals 0.1. If E and F are events defined by E equals A union D and F equals B union C, find the probability of E union F. Okay, I'm just going to highlight this so that we won't forget that these events are mutually exclusive. Okay, since they are mutually exclusive, you can say that PE plus PF by the definition given, P A union D plus P B union C, again using the formula given in the notes. So substitute the values. And you get 0.8. For question B, since E and F are mutually exclusive events, therefore P E intercept F is equal to 0.